Hi, everybody. Welcome to Speakeasy JS, the meetup for mad science, hacking, and experiments. I'm Faraz, and I'll be your host this afternoon. Mad science is about building things that make people say, I didn't know that was possible. So today, we're joined by Peg and Kieran from Magma Collective. Hey, guys. How's it going?
Hello.
Hello. So great that you're here joining us from two different countries at our new time, 10 a.m. Pacific time. Thanks so much for being here.
Thanks for inviting us. Yeah, it's really cool.
Yeah, I'm excited for your talk. So you'll be talking about Kappa Drive, and I think the title is Kappa Drive, making a set of hyperdrives appear to be a single one, which is, I guess for people who don't know what Kappa Drive is or what a hyperdrive is, that's probably a mouthful. So I'm hoping that we're going to learn all about it in your talk. So I'll just mention a bit about you guys' background. So you guys run Magma Collective. And I think the two things you work on are Cobox and Dark Crystal, both really cool sounding project names, by the way. So Cobox is a distributed, encrypted, offline-enabled data hosting cloud platform. And Dark Crystal is a set of protocols, libraries, techniques, and guidelines for secure management of sensitive data, such as cryptographic keys. Both really interesting sounding projects. I'm super excited to hear how Kappa Drive plays a role in those projects.
Yeah, right. Well, I guess when we'll get the slides up and we'll...
Yeah, let's do it.
You guys can see it?
Yeah, you guys can. The slides are up, and you can go for it whenever you're ready. It looks like Kieran might have frozen. Oh no, there he is.
Okay.
Hello.
Yeah, we can see
Kieran.
Okay. Yeah. I mean, so Kappa Drive, I think it started when we attended Data Terra Nemo a couple of years ago, and we're trying to think about how to solve this like distributed multi-writer problem. So Dat had built this like really amazing archiving file system called Hyperdrive, but it only permits, because it's cryptographically verified, it only permits one person to write at any one time to that specific hyperdrive. So we were like, this is great, but we want to be able to build like a shared file system where we can all kind of make writes and make reads and so forth. So that was the starting point for it. We came across kind of coincidentally, I guess, really shortly after kind of starting to think about it. So Carissa, or OK Distribute, people might know her, built something called PyraFest, which you can find on GitHub. On an airplane, I think she kind of came up with possibly a way of doing this, where you can aggregate multiple hyperdrives, which is like an abstraction of a file system, basically, that you can treat as if it is a file system. And yeah, so Carissa had built this kind of very like hack together on an airplane kind of prototype, or like kind of ideating the original idea, and then Peg and I kind of came across it around this time and picked it up, and we're like, this could be a really good basis for taking this idea forward and maybe ticking some of the boxes for something that we were looking after. So we kind of brought it a bit more up to date. We finished off the API, which maps the Hyperdrive API. It's kind of a replica of the Hyperdrive API with some additions, which is in itself a replica of the FS file system API. And we did this as part of the Cobox project, which was an EU-funded part of a program called Ledger, which is a Horizon 2020 project. This was the year before last year. I'm losing track. Yeah, the year before last and last year. And then we had some help from others along the way. Frando's pretty prolific on GitHub and was very active in the DAT ecosystem around this time, gave us a lot of help as well. So that's kind of the background, I guess. And then we can kind of go into some of the more details. Peg, do you want to give an overview of what Hyperdrive is? Yeah.
Yeah. So not wanting to assume too much that there's this hyperdrive thing is a file system abstraction built onto hypercores, of which each hypercore is an append-only log. I guess a bit the easy way of explaining it, or maybe the use case that was maybe because a lot of this came out of BitTorrent. I mean, I think the original ideas for it, or a lot of the inspiration for it, came from BitTorrent, which obviously for us you've been very involved in. And I guess it was the itch that it's scratching is a bit this problem of torrents being kind of static, that you can't update a torrent once you've got a bunch of files in a torrent archive. There's no way you can add an extra one in later. You have to kind of start a new torrent. So this the idea of building it on top of append-only logs, where you've got a kind of a set of messages, and you can always tack one onto the end, and turning that into a way of abstracting a kind of POSIX compatible file system, like an archive of files, was a bit the idea for Hyperdrive. So there was this thing which a great system, and it's kind of the one of the core components of kind of what kind of is sometimes called DAT, sometimes now called the Hyper protocol stack. And yeah, we were looking for a way of having more than one person write to it, which is obviously in having is a kind of asking for problems in terms of conflict, resolving conflicts. So we're using a way of aggregating together a bunch of these cores of these hypercores or hyperdrives in a way to make a set of them appear or act as one. And as an example, so we're relying on this module called Kappa Core, which some amazing people put together. And I think the kind of the primary use case or kind of flagship project of Kappa Core is Cabal, which is like a chat application, I guess, kind of a bit in the same vein as IRC, but working without servers. So it's a way of turning a bunch of feeds, and here we've got 3 people each having a feed, and each person can add a message to their feed, and rather than when you open the application, rather than seeing just 3 feeds with a bunch of messages in each one, we've got a way of turning that into a view, which is kind of like a chronological conversation, which is behind the scenes. What this Kappa Core module is doing is kind of whenever more information comes into one of these feeds, is building an index of them, and the view is kind of querying that index to figure out the chronological order of messages in this case, to be able to turn it into something that looks like a conversation. And then you can do nice things like being able to kind of block a person or whatever, removing all messages from one feed, or there's other interesting ways, or sorting messages into particular channels or sub channels and stuff like that they can do using this Kappa architecture. So I guess we're using much the same idea, but using this Hyperdrive, using a file system instead of chat messages. So each Hyperdrive is composed of 2 feeds. One is content and one is metadata. We are kind of so each person having 2 feeds, and we're kind of turning this set of a bunch of hyperdrives into one representation. So, for example, we've got here 4 people, and when each hyperdrive that belongs to each of those 4 people is only containing files that they've written to. So in this case, we've got 2 copies of one file, an older version of a new version, and then 2 other files. And what we see in the view is just the latest version of the file which is duplicated, and then all the other files which only appear once. So it's just a way of like turning a representation of a whole bunch of different files into like what we think is the current state of the archive when a bunch of people are writing to it. Should I keep going, Kieran, or do you want to step in?
Yeah, I mean, I just wanted to say, like, it comes with a bunch of problems, right? In terms of how do we determine who is the most up to date, who has the kind of source of truth, as it were, or like what is the most like advanced form of a file, and we're kind of having to deal with some of the problems like when people aren't online at the same time. How do you deal with a fork, like when one person performs a write to a file in one direction and one person performs a write to a file that goes in a different direction? How do you kind of how do we build a lens on this system that allows kind of anybody else who then syncs with those people to resolve that conflict and actually, you know, reconstruct a file that has some kind of meaningful representation? We gave it a go anyway, and I guess you'll kind of see our approach. So yeah, when we actually perform a write operation, what we're doing is we're building this kind of state object, which points to a list of. So when you perform a write on a file, right, we leave a set of links that have referred to this file before, which are previous writes to this file on anyone's hyperdrive. We can read that information, and we do that by sharing a message between each other, which we append to one of our metadata feed, which then is grabbed by Kappa Core, indexed into its own system, and then it builds this kind of shared state. So we're able to provide a set of like some kind of concept of history based on like the number of events, I think. So Peg's going to go a little bit more into that system, but effectively we do this read, we write some state, we store that, and then we replicate that and send that to everybody else. So yeah, next slide, Peg, I think. And then when we're doing a read operation, we have to figure out like who has the latest version of a given file. So we then are able to query our index and say like, okay, given this file and all that I know about this file that I've replicated from my other peers, what are all the like references that point to the most up-to-date one? And then I will we apply some conflict resolution mechanism. In this case, we use a vector clock, and then we fall back onto a Unix timestamp when that kind of doesn't work, which effectively returns us like the latest drive, hopefully, and then we perform a reader operation on that drive, which is how we're able to kind of aggregate these different file systems as one.
So the vector clock idea. So in the end, it turns out like we were looking at the code shortly before this. At some point, we stopped using vector clocks and went back to using just kind of these links, which are like references, previous references to file. So I guess both methods are the same concept of like you're measuring rather than using timestamps. To decide which is the latest version of a file, you're using people's knowledge of what went before in order to resolve conflicts. Partly because of like differences in clocks being a kind of very well-known problem in distributed systems, but partly also because of connectivity. It might be that there's somebody who just comes online having not been online and makes a bunch of writes which are the latest, but they haven't got the what's gone in between. So I guess it's the same, like coming back to the example of Cabal being a chat thing, it would be like somebody talking who didn't know the last 5 things in the conversation, and actually where their message belongs in the kind of causal history of what's happened is much earlier. than it is if you look at timestamps. So these vector clocks we implemented, and they kind of work by everybody has a clock which is just a number and an integer which is incremented every time that person experiences an event, which means in our case a write to the file system, and it can be either you writing or you being aware that somebody else has made a write. And as well as your own vector clock, you maintain your subjective version of everybody else's vector clock, which is what these little, on the diagram, these little arrays are. This is just an image off the Wikipedia article about vector clocks. And you pass around your version of the vector clock in these state objects that we're adding in every time we make a write. And we're using, and you can use them to figure out what the one with most knowledge kind of is the winner, the one who the person who makes a write who knows about the most of what's gone before, not necessarily temporarily the newest is the. So I'll pass back to Kieran to talk about Fuse.
Yeah, I'll do this quickly. I think we're coming to the end of our time. So, I mean, we added like a Fuse file system, which kind of uses Hyperdrive. The Hyper division have built Fuse bindings, and they maintain, well, like Macintosh, I think, maintains Fuse native. So they've written a bunch of bindings to Fuse, so we can build a file system and user space, which we wrote a wrapper for, and then we're able to mount this kind of shared drive on the file system, so you can treat it just like it's in your normal directory. Which is pretty neat, but it came up with a bunch of problems. So yeah, we learned a lot. Like we found there were some problems with the way that we approached this, but in general, we kind of found it works really well for archiving mostly static files, but to some degree of with some degree of change, and it works really well when you're offline. In terms of some of the problems that we butted up against a lot of the problems that are kind of still problematic in the ecosystem and this in general, which is the file system thing caused it was almost like it was sometimes too easy to access the file system, which then could lead to situations where you might end up with conflicts more frequently, or you couldn't perform read operations. There was kind of issues with flags and random access and so forth. Which was challenging, and yeah, ultimately it's not very good for changing a document at the same time. It just wasn't, because if you're opening a Word document, for example, and you're both editing two different versions of a cached temp file, it doesn't work. And then there's kind of problems in the ecosystem in terms of data duplication and kind of problems with Hyperdrive that we kind of haven't been resolved yet, and that we kind of inherited. So yeah, that was kind of some of the tricky parts. There's more stuff that can be done to Kappa Drive. We've got ideas, things that have changed in the stack since. And I mean, if anybody is interested in trying out doing any of these things, definitely approach us. And yeah, I don't know, is there anything else we wanted to cover, Peg?
I mean, I'd like to definitely flag up other approaches, particularly. I mean there's been a bunch of other things, and most recently with the unreleased Hyperdrive 10, there's a video where Paul Frazee speaks with Andrew and Macintosh about they're introducing some new primitives into sorry, I think it's not Hypercore 10, it's Hypercore 10. Yeah. So they're introducing some new low-level primitives into Hypercore that are specifically designed for multi-writer situations, which in some ways works on a similar principle. But it's kind of I recommend watching there's a recent live stream video where they kind of explain it. It kind of involves linking back to you can make a hypercore entry which instead of linking back to the previous entry in that hypercore, it kind of links back to an entry in another hypercore. And yeah, they're working on a system called Autobased to do kind of which will on top of Hyperdrive also be the kind of multi-writer thing. It's also auto merge by the ink and switch people, and hyper merge, which works using conflict free what are they called, conflicts, CRDTs,
resistant
conflict
data types,
data
resistant data types. Yeah.
And then
and then Ranger put together this multi-hyperdrive, right? Ranger Mauve, which I think is also another big head in the peer-to-peer space, was kind of doing this around the same time, just afterwards, as Kappa Drive. So we've kind of been keeping an eye on what's been going on in that package. So yeah, it's cool. The kind of summary is we did this as part of the Cobox project, which was kind of funded by the European Union, and we kind of released the version 1 last year. So if you want to check it out, there's some links. That's Kappa Drive.
Nice. Thank you for the presentation. Great. So if people have questions, post in the chat. Now is the time, and I will read them out. So I'll ask you some of my questions. You mentioned in the part where you were talking about what went wrong, that you had these hyperdrives, and then you kind of merge them together and synthesize a view over multiple of them. And you kind of covered it in the section, I guess, at the end where you're talking about limitations. But it made me think, each hyperdrive has a single writer, and so in order for somebody to modify like a file that's in this collective file system, they have to basically copy it into their own and write it into their own hyperdrive. So if you had like 100, you had a document that 100 different people have written or made changes to, then you're going to end up with 100 copies, one in each of the hyperdrives, if I understand correctly. So it just made me seem like that doesn't seem like that maybe the primitive isn't the right one, or maybe I don't know. So is that a fixable problem?
It becomes really unruly when you think about it, like with 100 different people, right? But like most of the time, it's not that many people editing a document is one thing. But like ultimately, you could diff it probably. There's different ways where you could like write a diff instead of actually writing a full content, and then you could compose state based on the differences of files, right? As opposed to like having to write the entire file every time. So I mean, more work could probably be done, to implement that. We did end up butting up against this. We kind of had deadlines and stuff, so we were like, we're just going to write the file. And then there was a lot of other situations where you kind of butt up against this as well, when like renaming a file was one mega problem that we butted up against, which was part of the normal file system API, right? So when you mount it in Fuse and then somebody wants to copy the file, but it's not supported in Hyperdrive at the moment. You kind of think that it could be in theory relatively easy, but I don't really understand kind of exactly what's going on as to why it wouldn't work at the moment. But kind of in theory, you could do a pointer right from file A to file B, say this file is no longer here and the file's over there. But instead, what we ended up having to do was do that ourselves, right? So we went, okay, well, if somebody else has written a file and you're deleting it, then you have to write a copy of the file that's empty and then delete that file in your one, so that other people know that the file has been deleted. So it's kind of, there was these weird kind of edge cases where, they're quite common actually, but you end up with these weird patterns of behavior where you have a lot of duplication of data, and there were some tricky problems that we butted up against that mean that it's like usable, but it's great for static files, right? It's really good. And then that's where we were like, it would be really nice if it's good for documents, but at the moment, in the state that it's in, it's kind of not a sustainable approach. But we learned through doing, right?
Mm-hmm. Yeah, so go ahead.
Sorry, I was just going to say, I mean, I think to some extent we were kind of hoping, because I think in some ways this is kind of a hyperdrive problem. Like if you think of the single writer situation, there's also this problem of duplication when you repeatedly make changes to a file. And so I think we were kind of hoping that that some of these things were just going to be fixed further down the stack, and that they kind of weren't our problems to worry about.
Mm-hmm. Yeah, that makes sense. Yeah. So, I mean, do you think that this is production ready? Like, should people build on top of this, or is this more of like just still has work to do?
I mean, we built Cobox on top of it, which is we've released an alpha, right? And it works. It works quite nicely. It works. I use it for kind of replicating stuff across multiple devices, and it works really neatly. And I can write from different devices and stuff. So it works really well at this stage between me and like a couple of other people who collaborate on a relatively slow basis, right? And we make sure. So what we've set it up with like one peer that's always online that replicates all of the data. So as long as one person's always online, I mean, in Scuttlebutt, you kind of have the concept of a pub, right? There's kind of in other peer-to-peer systems, there's somebody who's always available to copy the data and then seed it out to other people. As long as your collaboration is relatively slow paced, like you're not expecting it to be like live document editing, then it works really well. But I think, yeah, it's about understanding the limitations of the technology and then using it for the things that it works really well for. Like we use it for archiving, and it works really well for like storing images. It works really well for like documents that maybe we might want to change later, but we don't want to change now. Things like that.
So for the archiving use case, how is that? Like, what is the benefit of your system versus just a single writer hyperdrive? Like, because when you're archiving, does it change? Does it ever change later on, or like is it this? Yeah, I mean, maybe explain a little bit more about that.
I guess it's this thing of having a single view. No, is I mean, you could. I think there's easy ways you could go about this. To I guess there's other approaches to this, but having like a single view. I mean, if I think how we use a kind of we've been using Keybase as our for our organization's files, just stuff like meeting minutes after the meeting, not kind of live meeting minutes, but just a place to put things like contracts or administrative documents that we all kind of need access to. And yeah, if it was literally like a single writer archive, you'd need to like remember who it was that added that file, who it was from your organization. So I guess it's just I think there's probably a heap of other ways of doing it, but it's a way of like representative of having this view that anybody from your organization adds stuff, it's going to show up here in this place.
That makes sense. Yeah. And I guess my last question is about the EU funding. Could you tell me more about that? That sounds like a pretty cool opportunity that you were given to work on like fun peer-to-peer stuff and do it for the public good. How did that work? And was it an easy process? Do you think like other people should try to apply for the funding as well for their projects?
I mean, so this was the Ledger program, which was part of so the EU does this Horizon 2020 project, and then the Ledger was one of the kind of sub-projects of Horizon 2020, and they were given a bunch of money by the European Commission to find more projects who were proposing different systems that could help. It was mainly focused around kind of improving democratization, getting people to kind of start using technology that they felt like they had more ownership of. And I think there was a certain degree of like, Europe wants to reclaim its own technology in a way, instead of feeling like they're heavily reliant on a lot of stuff that's hosted in other countries. So yeah, it was a really interesting process. We learned a lot. There was like some really good events. We got to meet loads of really interesting people. And yeah, I think the project itself was a success. Like we kind of came out the end of it and we got the kind of extended funding to kind of produce a business case for Cobox. And yeah, I think it was a really good exploration. Cobox now is like, we've received some further funding. We're kind of continuing development in different areas and kind of doing some more user research basically to kind of see how people might use this. Like it's come from like trying to have a dialogue with people who are interested in this. So we've kind of really tried to center people who are interested in it as part of the design process, which has been really beneficial for the project itself and really beneficial for us as well. Yeah, Peg, do you have anything to comment on the Ledger program?
I mean, it was great. It was a great experience. I don't know whether they're I mean, there's currently another round of Ledger running. I don't know whether there's like a call for like a further round or not. But like, yeah, I would totally encourage people to other projects to look into it if it fits them. I guess the thing which was maybe different to other like grant funded projects that we've done is that it's kind of this kind of a accelerator program, or like it's not just like throw some money at an open source project for the sake of like having some good thing that comes out of it that anybody can use. It's kind of meant as like you're supposed to have a business model and be kind of preparing yourself for having a sustainable business, which was something that for us was quite like new. and yeah, I mean we're still dependent on grant funding. We haven't really started as a business, and we haven't really figured out how to turn this into a business, and I don't know if we ever will.
Right. Cool. Well, thanks for presenting your work at Speakeasy.